All right, feel free to come inside, take a seat. And I'd like to say good afternoon. I'm Eddie Ramirez, Vice President of Marketing. I'm in charge of the go-to-market and ecosystem efforts for ARM for the infrastructure line of business. For us, infrastructure is a very important business. It represents cloud data centers, networking equipment providers, 5G infrastructure, HPC, and of course, most importantly, AI infrastructure. And what I want to talk to you about today is how we're working collaboratively with the industry to develop specialized workload-optimized silicon that is powering the infrastructure. And particularly, this is going to be critical in this new age of AI, where customized silicon is going to be able to power and unleash new performance in a sustainable manner for AI workloads of today and in the future. And I think it was great that we heard so many sessions this morning focused on AI, because the industry is not only looking at how to deliver the benefits of AI across the application space, but also of how to actually scale hardware to be able to support the increased compute infrastructure that's going to be necessary to deliver those gains. When we saw some of the presentations this morning that looked at parameter size of models that were growing exponentially, it also means that the infrastructure itself has to grow to be able to handle the large language models. Today, there is such an intense focus on building the large language models that can be used and proliferated in applications of tomorrow. But what you'll see is that in the future, 80% of CPU cycles and compute cycles in the data center will actually be driving inference. And inference is still at its infancy in terms of being able to be run at scale. And we want to be able to have inferencing run not only in cloud data centers, but also in edge devices and even in the mobile devices that many of you are carrying in today. And so for us at ARM, it has really been our mission to try to unlock a broader ecosystem of specialized silicon that can be used to build this kind of hardware. And sustainability has got to be at the heart of that. Most data centers are actually driven by a set power budget. So the compute can only scale if the power can be able to be harnessed efficiently. And so the solutions that are required to do that tend to be more and more custom solutions within the cloud service providers, but even within the market in general. And one of the things that's driving this trend of customized silicon is being able to have more reusable blocks to build these solutions. ARM answered this call with our compute subsystems. We introduced our Neoverse compute subsystems to give partners more flexible building blocks than disaggregated IP. And that's important now for us to be able to take these building blocks, tune them for the most performant leading edge process nodes, and do so in a way that our partners can access custom acceleration and build that into the SoCs of tomorrow. And so we have to do this in a way that also addresses the complexity and the cost of building custom silicon. That's really how we unlock that for a broader set of the market. So when I talk about specialized processing, think about 5 years ago. A lot of the discussions around AI we're even talking about a year ago, but let's take you back to 5 years ago in 2018. The predominant compute architecture was an x86 processor with about 28 cores that was being used in everything from cloud data centers, 5G, or at the time 4G infrastructure, as well as edge. And it was the same silicon that was being deployed across a variety of market landscapes. That has changed dramatically in the last 5 years, and ARM has been at the heart of this transformation. We are now seeing cloud-native processors by our partners like Ampere that are now delivering over 100 cores, 6x more cores than what we saw in 2018. We're seeing partners like NVIDIA who are delivering AI and HPC-focused processing that is unlocking 3 or more times the memory bandwidth. And we're seeing at the edge performance per watt benefits of over 4x with ARM compute solutions. And then you have other accelerators like DPUs, which are actually unlocking 30% more cycles for cloud VMs because they're offloading a lot of the infrastructure tasks that were previously occupying these compute cycles. And then you've got within 5G, a delivery of increased bandwidth as well as power efficiency, with today's 5G infrastructure delivering 72% power efficiency over prior generation. And so this is happening because of a proliferation of specialized compute. And that proliferation can only happen if there is still some standardization and some commonality so that the software can be common across all these platforms. At ARM, we've invested for the past 10 years in creating a vibrant, robust software ecosystem that can run across all these different custom silicon devices. So where do we go next? Well, I mentioned development cost. If you look at today, developing silicon on a leading edge process like 2 nanometer, you can look at over $500 to $700 million in a project involving the silicon and the software cost of developing that project. That means that placing bets on silicon is becoming quite a significant decision for a lot of not only cloud operators, but even OEMs and the broader market today. So we want to be able to offer lower risk paths to achieving custom silicon on leading edge nodes. That means we have to work very closely with the ecosystem to achieve that. We also want to be able to provide faster time to market. We can't get bogged down in long development cycles because the market is changing so dynamically. You can't design AI silicon that isn't going to be flexible to address changes in the marketplace. And lastly, we want to be able to make it as easy as possible to add acceleration to these designs. So in August, we actually introduced to the market our Neoverse CSS compute subsystems. They basically integrated various parts of our ARM IP in configurations that were optimized for PPA, power, performance, and area, and that they were able to be designed into leading edge nodes as easily as possible. So it really was offering the basic building block for custom SoCs. And it was able to be done in leading edge performance and leading edge technology. But CSS doesn't build the final silicon. We still need to have third-party IP to deliver a choice of memory and I/O. We need to be able to have partners and EDA tools that are optimized around CSS design flows. And so we've worked with this industry in a very collaborative manner, which is, if you think about it, the theme of OCP this year. And we're able to deliver a complete platform where you can now integrate all of the best technology from throughout the SoC design ecosystem. And so that includes third-party IP, that includes chiplet technologies, that includes commercial software and firmware. The end-to-end design process is what we're now working together by harnessing the power of the ecosystem to deliver to the marketplace. And so it's a pleasure that today we announced ARM Total Design. ARM Total Design is an ecosystem program that is focused on frictionless delivery of custom SoCs. Several key partners are part of our ARM Total Design program. Third-party IP vendors, which are pre-validating their IP for our ARM Neoverse CSS compute subsystems. We've got some of the largest ASIC design partners who are working with us today on being able to deploy and design around Neoverse CSS designs so that they too can add custom integration, custom acceleration pieces into the SoCs. And we're announcing partnerships with 2 of the leading foundry partners to be able to take advantage of their leading edge nodes as quick as possible. And the last piece that's also important in the silicon design process is the firmware. Most of the time, firmware is actually written after silicon comes back. We're now working to enable firmware to be actively written and developed while the silicon is being designed. And we have now got partners who are working with us to offer commercial firmware for our Neoverse CSS designs. All of these are important steps to be able to drive time to market and efficiency in design. So the initial phase of ARM Total Design brings 13 partners who are leaders in their particular fields. We've got partners like Cadence, Synopsys, and Rambus, who are all leaders in developing memory, security, and peripheral IPs. These are IPs that are critical to finishing a custom SoC design. They're also the leading edge partners in EDA tools, so that we're making sure that the EDA tool flows are optimized for very high core count systems. We've got ASIC design partners across the globe. For example, ADT in Korea, SocialNext in Japan. We've got Alpha Semi here in the Bay Area, Faraday in Taiwan, and Synopsys and Capgemini in EMEA, offering a global footprint of ASIC design partners that can now help take these designs to completion. And we're very excited to have Broadcom as part of our program. Broadcom is actually one of the largest ASIC design partners in the world, and delivering a lot of the custom AI silicon that you see in CSP data centers today. And last but not least, Intel and TSMC are critical foundry partners to be able to deliver the manufacturing footprint and the leading edge foundry technology that's going to be necessary to drive AI workloads of tomorrow. So what have we achieved with CSS and through the ARM Total Design program? We've been able to take two partners that I'll call out as examples here. Partner A was able to deliver working silicon within 13 months of kicking off an SoC design. This was effectively a 100+ core count design. And if you think about the 13 months, that includes the 4 to 5 months of cycle time in the fab as well. Normally, an SoC design could take 2 years. And so we've been able to achieve significant reduction in time to market through Neoverse CSS and the ARM Total Design program. We had a second partner who looked at building custom silicon and was able to calculate savings of 80 engineering years saved because of the fact that we are now delivering pre-validated, configured IP that makes it much simpler for them to be able to do very complex designs with less engineering resources. And that's powerful because we're now able to be a catalyst in actually increasing the amount of partners who can actually have access to design, deploy custom silicon. And I want to announce what we're working with in terms of a partnership with a few of the partners in ARM Total Design. SocialNext and TSMC and ARM are working together to bring to the market multi-core chiplets. These are 32-core chiplets based on ARM Neoverse CSS that will be manufactured on TSMC 2-nanometer process. What you will find in the future is that the chiplet becomes the new building block for custom SoC designs. The reusability of chiplets will bring even further benefits in terms of savings when you look at these design points. And so we're very excited that as part of ARM Total Design, both of these partners are announcing this new initiative that will take place in deploying multi-core chiplets. We'll be able to use these chiplets to drive POCs in hyperscale cloud processing. You can think about designs that are 128 cores with 4 chiplets and an I/O hub. You can look at 5G, 6G infrastructure designs that incorporate chiplets with custom acceleration. And you can even look at edge AI SoCs. So ARM is committed to developing an ecosystem for chiplets, not just through the ARM Total Design program, but also through initiatives where we are actually driving within standards organizations like UCIe, CXL, or even within our AMBA-CHI chip-to-chip protocol collaboration group. And it's part of an initiative to make sure that the next wave of SoC designs can be done as efficiently as the current generation of designs, with chiplets as a key technology point. So I want to close with this. If you think about the heart of these system designs, the silicon decisions that often get made are the first decisions within a system architecture. And now you're able to allow a broadening of heterogeneous compute throughout the industry, which will support AI in a variety of applications today. And to do this efficiently, performant, and in a manner that's as cost savings and fastest time to market as possible is really what we're delivering with ARM Total Design. So thanks for learning more about the design. We are at the ARM booth at 3 o'clock. We'll actually have a lot of our partners join us at the ARM booth. So if you have any questions of how you can utilize the ARM Total Design ecosystem, what some of the partners are doing besides some of the information I presented to you today, I welcome you all to join us at the ARM booth and learn more. And we can even work to find a partner or two that can work with you on your next gen custom SoC design. Thank you.